Neural networks seem so complicated, but they're not.
Hey, welcome, hello, good morning or evening, or any time you watch this. Sit back and let's start our today's podcast.
Hey everyone, welcome to our dialogue on neural network.
Wait it before we get started this podcast. I have to say that this is produced and directed by Telmsani Mohammed, Zaza Ilyas, Ilaw Afi Abdurrahman. Let's continue and sorry for my terrible voice.
Hey everyone, welcome to our dialogue on neural network. I'm Mohammed Telmsani and I'm joined by my friend Ilyas Zaza.
Hi everyone.
Abdurrahman Al-Wafi.
Hi there.
We've pretty stoked about today's topic because we're diving into the world of neural network. Now, if you're not sure what those are, don't worry, we've got you covered. But first things first, why we are talking about neural networks today?
Well, neural networks are everywhere, right? They're like the brains behind so much of the tech we use daily.
Exactly, from voice assistance to image recognition, neural networks are shaping our tech landscape. So today we're going to break down the basics and chat about why they're such a big deal.
And we'll throw in some real-world examples to keep things interesting, right? So trust me, you will want to hear these from me.
Absolutely. So whether you're a tech geek or just someone curious about the tech world, this conversation is for you. Neural networks are not just tech jargon, they're the wizards behind the center of modern technology.
And we're here to demystify it all for you.
So grab a cup of coffee, sit back, and let's dive into our neural network chat right here.
Exactly, can't wait to get started.
Alright everyone, grab your coffee because we're about to take a deep dive into the mesmerizing world of neural network. Zaza, earlier we touched upon neurons and synapses. Could you elaborate a bit more on these essential elements?
Absolutely. Think of neurons as the MVPs of our neural network team. Each network processes information and synapses are like the lines of communication between those layers. They pass the ball, or in this case, information from neuron to the other.
Great analogy. Now let's build on that foundation. Wafi, explain to our listeners how the layers in neural network work together.
Sure thing, imagine the layers as the stages of a rocket launch. The input layer is the countdown where we load our data. The hidden layers are like different stages of the rocket, each contributing to the journey. Finally, the output layer is the launch giving us the result, the payload of our neural network journey, right?
A fantastic rocket metaphor. Now Zaza, let's spice things up a bit. Activation functions are crucial. Could you help our listener understand this all?
Absolutely. Activation functions are like the conductors in an orchestra. They decide when each instrument or neuron should play. It's what gives our neural networks its unique tune, determining whether the output is harmonious or not.
Perfect.
Beautiful analogy. Now let's bring it down to earth. Imagine you're playing a video game. Luafi, the input layer is your controller. The hidden layer are the game processing your moves. And the output layer is a screen showing your results. Activation functions then are like the game mechanics deciding your fate based on your performance.
Exactly, Tlimsani. The more you play, the better the game or the neural network gets. It's a learning process.
Spot on. Now let's tie all together with a real world example. Zaza, shall a practical scenario with neural network really shine?
Imagine you're scrolling through your social media feed, uploading photos. The neural network recognizes faces, suggests tags and filters out anything inappropriate. It's like having a digital assistant that curates your photo album and hiding the malicious content.
Amazing! We've covered a lot of neurons, synapses, layers, activation function, and even a rocket launch and orchestra performance. Stay tuned, everyone, because in the next segment, we're talking our neural network knowledge to even greater heights. Welcome back, everyone. We just scratched the surface of neural network, and now it's time to explore different types out there. Elwafi, kick us off by introducing the first type.
Absolutely. So we have these amazing neural networks and they come in different flavors. One of the classics in the feed-forward neural network pictured this as a one-way street. Information goes from the input layer straight to the output layer without looping back.
Great analogy. Now, Zaza, let's talk about recurrent neural networks. How are they different and what they strength?
Okay, we call the orchestra I mentioned earlier. Well, a recurrent neural network is like a symphony that can loop back on itself. It retains memory of past inputs, making it fantastic for tasks like predicting the next word in a sentence or understanding context in sequences, just like ChatGPT we all are familiar with.
Fascinating. Now, Ruefi, enlighten us about convolutional neural network. What makes them special and where do they excel?
Think of convolutional neural network as specialized detective for images. They are fantastic at recognizing patterns in visual data. Just like detective focus on specific aspects of a case, convolutional networks zero in on local patterns, making them making them ideal for image recognition and classification tasks.
Amazing. Now let's dive deeper into application. Zaza, how about you share some specific scenarios where feed-forward networks shine?
Okay, let's imagine this scenario when you are on a e-commerce website. Feed forward networks work behind the scenes to recommend the products based on the history of your search on this website. They're like the personal shoppers of the digital world, making your experience more tailored.
Excellent. Ruefi, let's talk about the strength of your recurrent neural network. Where do they truly excel in real-world application?
Exactly, Tlimsani. Consider language translation. Recurrent neural network with their ability to remember context are like language maestros. They can understand the nuance of sentences and provide more accurate translations.
Fantastic example. And finally, Ruefi, tell us about the application where convolutional neural network stand out.
Okay, Tlimsani. So picture medical imaging. Convolutional neural network are like superpowered radiologists, analyzing images to detect diseases. Their ability to recognize intricate patterns make them invaluable in healthcare.
Incredible. We've covered a lot: feed-forward, recurrent, and convolutional network, along with their unique strength and application. Stay with us, because in the next segment, we're delving into the nitty-gritty of training these powerful networks. Don't go anywhere! We've explored the diverse world of neural networks, and now it's time to pull back the curtain of how these networks learn and evolve. Zaza, break it down for us. How do we train these neural powerhouses?
Absolutely. Training neural networks is like teaching a student. It takes examples and corrections. The first step is providing them with input, data, and labels in machine learning context. Think of it as a teacher showing a student pictures, cats and dogs, labeling each one.
Excellent analogy. Now, Ruafi, let's talk about loss function and optimization. How these play a role in refining the learning process.
Loss functions are like report cards for our networks. They measure the difference between their predicted output and the actual result, of course. So optimizations is the process of fine-tuning the network to minimize this difference, making it better as the task.
Great explanation. Zaza, dive into backpropagation and gradient descent. What's happening behind the scenes during this phase?
Backpropagation is like feedback from a teacher. If a student makes a mistake, they receive feedback to correct it. Similarly, backpropagation adjusts the weights in our neural network based on the error, making it more accurate over time. Gradient descent, on the other hand, is like finding the optimal route to the correct solution. It's about tweaking the parameters to reach the best outcome of efficiency.
Fascinating. Now, Luafi, let's touch on the importance of datasets in training. Why is having the right data crucial for the success of neural networks?
Okay, so imagine training a chef without ingredients. Datasets are the ingredients for our neural network. Having diverse representative data ensure that the network learns robustly, and can handle a variety of scenarios. It's the secret sauce for success.
Love the analogy. So, to sum it up, we start with input data and labels, use lens function and optimization to refine, implement backpropagation and gradient descent for adjustment, and ensure success by having the right dataset. Zaza, any real world examples?
Of course, consider speech recognition technology. The more diverse examples of speech it's trained on, the better it becomes at understanding various accents and languages. It's all about exposing the network to a rich dataset for comprehensive learning.
Incredible! We demystified the training process from data input to fine tuning with loss function and optimization, and the importance of robust datasets. Stick around because in the next segment we explore real world applications that showcase the power of this linear neural network. Don't go anywhere! Wafi, let's shift gears to image recognition. How are neural networks changing the game in this field?
Okay, Tlemcen, so think of neural network as the ace of technology. In image recognition, they are used for facial recognition, object detection, and even in autonomous vehicles. For instance, they can identify pedestrians, traffic signs, and obstacles, making our roads safer.
Amazing application. Now Zaza, let's talk about natural language processing and how neural networks transforming our interaction with language.
So, neural networks are language maestros. In natural language processing, they power virtual assistants, chatbots, and language translation services. Google Translate, for instance, uses neural networks to provide more accurate and constant context-aware translations, breaking down language barriers globally.
Incredible! Now let's round off this segment with success stories. Luafi, share a notable example where neural networks have made a significant impact.
So consider AlphaGo, the AI developed by DeepMind. It demonstrated the power of neural networks by defeating world champion Go players. They showcased the immense potential of AI in complex problem solving and strategic thinking.
Absolutely, mind blowing. We've covered practical application in healthcare, finance, image recognition, and language processing, along with remarkable success stories. In our final segment, we wrap things up and explore the future of neural networks. Stick with us and don't miss the conclusion of this exciting journey. Thank you, guests
You are
and
welcome.
viewers,
You're welcome.
for being part of today's exploration. If you enjoyed our discussion, be sure to tune in for more exciting episodes as we continue to unravel the mysteries of technology. Until next time, this is our podcast expressing our gratitude and signing off. Remember, the future is powered by neurons and your path for this incredible journey. Take care and happy listening.
كان محمد كان شيء